Good afternoon, everyone. Today we're going to start doing our video lecture series for Math 35, College Algebra with support. This section is going to be on 3.1. I'm going to try to do one section per video. I've got a pad open over here to write on for you. You can see me while I talk, and I've got MathLab open so we can work on some problems during the course of the lecture as well. So let's just dive right into it. Chapter 3 is on polynomials and rational functions. You're going to see me turn my head to the side a lot because that's where the pad is. But I will do my best to look at the screen as often as I can. So a polynomial is a sum of terms with variables containing different coefficients, or I'm sorry, different exponents, and possibly different coefficients. They don't have to be different, but they can be. So we call an nth degree polynomial, nth degree polynomial, it's a polynomial. The term with the largest exponent has an exponent of n. That's all that means. We write them as a sequence of characters. We will put things like this: a n x to the n plus a n minus 1 times x to the n minus 1 plus a n minus 2 x to the n minus 2. And as the exponent keeps going down by 1, we're just labeling this a different coefficient until we finally get down to a1 x to the 1 plus a0. Okay? And so this is just a notation for saying, like, the subscript matches the exponent. And it's done to indicate which coefficient goes with which exponent. We won't do a lot with it now, but later near the end of the semester, this is going to come back. Okay. I will do my best to pause every once in a while. Make sure you have time to take notes, but if anything, just pause the video while you're watching it and take notes. You can always rewind. These will also be uploaded to YouTube. And I will list the link at the end, what my subscription name is. You'll like it, I hope. We have a shortcut for writing this. We write this as, it's got this funky looking E. And we're going to write k equals 0 and n up top. And then we'll say a sub k x to the k. And what this means is you start with k equals 0. K is going to cycle through numbers. K equals 0, then 1, then 2, then all the way up to n minus 1, and then n. And so I have a sub 0 x to the 0 plus a sub 1 x to the first power plus a sub 2 x squared plus a sub n minus 1 x to the n minus 1 plus a sub n x to the n. I'll give you a shorter list in a second. This is a general notation. You will see this a lot in calculus and things like that. We will also see it at the end of the semester when we're looking at sequences and series. So take a look at that, take some notes on it. I will point out k is always an integer. And usually a whole number, a whole or natural number, which means no negative numbers. We generally start with 0 and go upwards. So if I have something like k equals 0 to 4, I'm saying a sub 0 x to the 0 plus a sub 1 x to the 1 plus a sub 2 x squared plus a sub 3 x cubed plus a sub 4 x to the 4th. Well, I wrote that notation a little bad. Let's try that again. A sub k x to the k equals a sub 0 x to the 0 plus a sub 1 x to the 1 plus a sub 2 x to the 2, a sub 3 x cubed, and a sub 4 x to the 4th power. Ignore that first line. That was bad. Bad juju. And of course, we wouldn't leave it like this. What's any variable to the 0 power? Anything to the 0 power. It's 1. So we're going to make it equal to 1. And so a sub 0 times 1 is just a sub 0. On the variable where we have an exponent of 1, we don't put the exponent. It's an invisible exponent. So this character might look a little new to you. Unless you've used Excel. This shows up in Microsoft Excel a lot. It's also in statistics. I don't think many of you have taken statistics. It is the capital Greek letter sigma. Sigma. And what it means in math, it means sum up what follows. The k equals 0 to n. These two parts tell us what the starting exponent and ending exponent have. And ending exponent will be. Of course, one you're very familiar with. Why don't you take a second, pause the video, and see if you can figure out what this is going to be written out as. I'll assume you paused and worked it out. This is a sub 0, x to the 0, plus a sub 1, x to the 1, plus a sub 2, x squared. We've got an x squared, an x, and a number with no variable. X to the 0 is 1. You know this quite well as ax squared plus bx plus c. This is a quadratic function. All right. I assume that's giving you enough time. Let's turn the page. And quadratic functions are what section 3.1 is about. So 3.1 is on graphing quadratic functions. We start off with, well, we usually say f of x, but recall that's the same thing as y when we're graphing. Ax squared plus bx plus c. That's a common form to do it, where it starts in. It's not usually one of the easiest ways to graph it. So let's start with the easiest way to graph it. The graphing form, or the ideal form for graphing, is y equals f of x, and it's a times x minus h squared plus k. So a, it vertically stretches or shrinks. Shrinks. Put a box around the equation because we're going to use it a lot. If a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. The h represents a horizontal shift. H greater than 0 means go right h units. H less than 0 is left h units. And it's very, very important to note, very, very important. See that minus sign right there? That minus sign is not part of h. The minus sign is not part of h. If it says x minus 2 squared, h equals positive 2. If it says x plus 1 squared, h equals negative 1. So it's the opposite of what it looks like. That's the way I remember it. Let me pause and let you hit pause and take some notes. Okay. And K, since H represents the horizontal shift, K represents a vertical shift. K greater than 0 is up K units. K less than 0 is down K. And here it has the same sign. Sign is what's shown. So if we have y equals a times x minus h squared plus k, we are going to move right h units and up k units. For every point on the original or base graph. And the base graph is, it's got x squared. The base graph is y equals ax squared. So a handy way of thinking about this we're going to have our vertex at HK. That's the bottom of the dish or top of the hill. It's there or there. Fascinating. Kevin Hart's expecting a second child. I love how Google likes to spam me on this. And the reason why the vertex happens where occurs where f of x switches from decreasing to increasing, or increasing to decreasing. Decreasing to increasing means it's the value is going down, 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 and all of a sudden it starts going back up, and the vertex is right there. Increasing, it's going up, 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 and all of a sudden it stops and it starts going back down. All right, you ready for some more? Let's put this together and show how this is a lot handy for graphing. I've been giving you a lot of the math jargon. I don't know that it's all that helpful until you dive deeper into the math rabbit hole. And you guys are getting there, but you're just starting to wade into the pool. Okay. So what we're going to do, let's start with, we're going to have f of x equals a times x minus h squared plus k. Step 1, Find and plot the vertex. And it occurs at HK. Remember, same sign, opposite sign. Once we've found and plotted the vertex, you might find it handy to make a table. So when x is 0, y equals 0, and y equals a times 0 is still 0, which means no shift from vertex. This is our vertex right here when x equals 0. Well, sorry, when x equals h. This is just plotting. We're making a table. What we're doing here is plotting movement from the vertex. Next, I'm going to take a look at going left or right one. Left one or right one is the same thing as plus or minus 1. When I square positive or negative 1, I have 1, which means up 1. And if I multiply that by a, I get up a units. If I go left or right 2, this is plus or minus 2. Positive 2 or negative 2 squared is positive 4. This leads to y equals going up 4. And when we multiply that by a, we get up 4a units. So altogether, from the vertex, we have a point at the vertex. That's our 0 or center. Then a, we go left or right 1 and up a. And we go left or right 2 and up 4a. If a is negative, going up negative means going down. Pause and let you write that down. Get a swig of coffee. I hope you guys are staying safe right now. We have one of the most cases in the county, or the county, local counties. And I know most of you are young whippersnappers, but your family aren't. And you don't want to take it home and get grandma sick. So try to avoid the large crowds. They've already shut down the movie theaters and bars and dance clubs and stuff like that, but try avoid hanging out in large groups. All right? something you can use while you're doing this is called the axis of symmetry. Let me go ahead and pause if you need to, write it down, okay? Step 3, axis of symmetry can make step 2 shorter. I'm going to abbreviate axis of symmetry as AOS. And for y equals a times x minus h squared plus k, the axis of symmetry is x equals h. What this does is x equals h, it acts like a mirror. And recall, when we have x equals a number, this is a vertical line. So it's a vertical mirror. And so if a dot appears on the right of the line, a dot's going to be the exact same distance on the other side. Vertex is always going to lie on it. The AOS, it's right there. So all we need to do is really just plot or find going right 1 and right 2, or plus 1 and plus 2. Find the corresponding y, find the change in y, and then mirror it across the axis of symmetry, or reflect it. All right, you guys ready to do some examples? All right, let's just dive right into the deep end of the pool. We're going to start off, our first example is going to be f of x equals -2 times x plus 3 squared plus 5. Okay. Step 1. Find the vertex. The vertex is at HK. And I'll pause, give you a second to think about what it is. If you can look back at what we did before or talking about before. Recall, H is the opposite sign of what's inside the parentheses, and the same sign as what K is the same sign, so what's outside the parentheses. So I've got -3, 5. Now I'm going to make a table. And I'm going to use my axis of symmetry to shorten it. I don't need to do as much. I have x squared, and now a is -2, so I'm going to have -2 times x squared. If I go right 1 I square 1. 1 squared is 1, and I'm going to go up 1. And that's x squared. So what this next part of the table is saying is do -2 times that up 1. And I get -2, which is down. And if I go right 2, I'm squaring the 2 because this says x squared. That's where I'm getting the idea of the square. That's 4, and that's normally up. But I'm going to modify that 4 up by a, and a is -2. -2 times 4 is -8. -8 is a negative number, so we're going to go down. My axis of symmetry x equals h, or x equals -3. You might make a dashed line, a faint dashed line for it. Can help. All right, I'll pause, let you gather all that, and then we'll put all this together into the graph. Okay. My vertex is at -3, 5. I'm going to mark my y-axis, my x-axis. That's -3, 5. I'm going to go, this makes my vertical line right here, my axis of symmetry. I'll make it real faint. And when I go right 1, I want to go down 2. So right 1, down 2. And I literally just do little dots as I'm doing it. Right 1, down 2. And then I got to go down quite a bit for the second one, so I'm going to add some more lines. The next one is right 2, down 8. This is from the vertex. Both are from the vertex. So here I'm going to go right 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8. So that one's right 2, down 8. That one is right 1, down 2. And now I'm going to use my axis of symmetry as a mirror. This one is 1 unit away from the axis of symmetry. I'm going to go 1 unit left right there. This one is 2 units from the axis of symmetry. I know it is because I moved right 2. So I got to move back left 2. If I move back left 2, I'm doing that. I'm going to go left another 2 to make it a mirror. And now I've got 5 points of my parabola, and I can just connect the dots, and don't make that end a point. Give it a little bit of a curve. It doesn't have to be a strong curve, but that's definitely not like a triangle. It's not a spear tip. It's curved. Any questions on that? All right. I'll assume you've paused it and you're ready to move on. so here we'll do next example. F of x equals 1/2 x minus 2 squared minus 4. So remember, we want our vertex. It's at HK, which is the opposite sign of what's in the parentheses, +2, same sign as what's outside, -4. I wonder if I can move that camera over here. There we go. Now I'm not like off center. Much better. I can do my little table. X squared. And A here is 1/2. So 1/2 x squared. And you're going to notice the first two steps of this is going to be the same. I'm going to take that down a little bit. Both of these start off as going right 1 and right 2. And when we square those numbers, remember we're squaring them. This is what we're doing. I'm squaring that. This is going to be up 1 and this is going to be up 4. It's always the same. There's a pattern. Right 3, up 9. Generally, when you start going right 3 and up 9, you're making your graph really big. But if you need those points, you can. Now, we're going to take this 1/2 and multiply it by everything there. I'm only going to go up 1/2 now. And I'm going to take the 1/2 and multiply by the 4. I'm only going to go up 2. I can take the 9 and multiply it by 1/2, and it's up. 1/2 of 9 is 4.5. Sometimes when you have A is a fraction, you can actually get away with doing more points. Go right 4, I square 4, that's 16. 1/2 of 16 is 8. My axis of symmetry is at x equals h, which is x equals 2. And now we've got the center of our graph, the vertex. We've got the movement we want to do to the right. Well, I guess to you, you'd be looking that way. And then we have our mirror, and we're going to just reflect across that axis of symmetry. So let's go ahead and do this. Y, X, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Don't know how many I need. I need quite a few. My axis of symmetry, I said, is x equals 2. I'm just going to make a little dashed line so I know it's there. Okay? I'm going to plot my vertex. My vertex is at 2, -4. I'm going to go right 2, down 4. That's my vertex. Then I'm going to start plotting that movement. I want to go right 1, up 1/2. That's not very much, is it? When I go right 2, I'm going to go up 2. When I go right 3, 1, 2, 3, I'm going to go up 4.5. 1, 2, 3, 4.5. And if I go right 4, I got to go up 8. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to reflect everything across. And now I bring in a nice little lazy curve. Keep that curve rounded. Put arrows on the end of your parabola. So keep the vertex rounded. That's important. And put arrows on the ends. You know why we put the arrows on the ends? It lets us know that that line keeps going. It doesn't stop with those last points. Okay, it's pretty important. And it doesn't take a lot of extra work. Let you finish that. Pause, take a picture of that. Well, or write out the notes, preferably. Writing out the notes is far superior than taking pictures. The process of taking it through your brain, out your hand, writing it down, it really helps you memorize it. It really does. One advantage to video lecture is I can give you the next problem to work on your own. Just tell you to pause for 10 seconds. You pause it and I'll keep going with the video. Some of you will do it, some of you won't. But hopefully you all do. What I want you to do is I want you to try this. Your turn. F of x equals x plus 1 squared minus 2. I want you to graph that. So find the vertex, find your movement, axis of symmetry. In class, we would pause for 5 minutes. I want you to just hit pause. Okay, I'm going to assume you paused it and did it. I have a vertex. Opposite sign of that one is -1. Same sign is -2. Which means my axis of symmetry is x equals -1. And here, a equals 1. So the table is easy. Right 1, right 2, up 1, up 4. You're really better off just memorizing the sequence, but it's coming from the squares, okay? When I graph it, I don't stop to think about that, why it's doing it. I know why it is, but it's easier just to remember 1 and 1, 2 and 4, 3 and 9, because they're the squares. All right. I need a vertex at -1, -2. And I want to go right 1 and up 1, right 2 and up 4. Axis of symmetry. I will reflect across the axis of symmetry. And voila. You guys ready for a more challenging one? Let's see, which approach do I want to do next? Well, let's go with something like this. I'll actually have another graph in my notes. Maybe we'll just do it real quick. 2 times x minus 4 squared minus 6. I want you to pause it and try to graph that on your own. I'm going to assume you did. So what do we have here? Our vertex is going to be at HK. H is the opposite of what's inside, it's positive 4. K is the same as the outside, negative 6. I've got an axis of symmetry at x equals 4. I'll make my table. Now I need to look at 2x squared because a equals 2. So I go right 1 and right 2 leads to up 1 and up 4. And then I'm going to take that 2 and multiply it. So this 2 times 2, up 2 and up 8. Okay. So I've got a vertex at 4, 1, 2, 3, 4, negative 6, 3, 4, 5, 6. I'll put my axis of symmetry in. I'm going to go right 1 and up 2, which means left 1 and up 2 to mirror it. And I'll go right 2 and up 8. I know I'm down 6 already, so going up to here is just adding 6 and then 2 more. And then we'll mirror that across. It's right over there. And we'll connect our dots. Okay, so let's go crazy. You ready for crazy? I've been giving it to you in this form. What about when it's not in this form? I'll assume you've paused and taken the notes you need. What if we have it in a regular old ax squared plus bx plus c? You're going to find that the vertex, and this comes from completing the square. We'll actually do this later. The vertex H is at H equals negative b over 2a, and k equals f evaluated at negative b over 2a. Okay. when you have it in this form, it's also kind of easy to go with the y-intercept rather than doing the up and all of the other stuff. So in this form, so find the vertex and find intercepts. If I plug in 0, I'm sorry, when the y-intercept is when x equals 0. So I've got y equals f evaluated at 0, a times 0 squared plus b times 0 plus c. My y-intercept is just 0c. This whole thing is the y-intercept. I know there are problems in MATLAB where they just call the y-intercept that. So some My MATLAB problems call that the y-intercept, just the c. I think that's poor form. It's a coordinate. And x-intercept is when y equals 0. So you have ax squared plus bx plus c equals 0. And you can either do factoring, quadratic formula, etc. Complete the square to find those 2 points. Okay? So let's start off with one. Y equals x squared plus 2x minus 5. Okay, that's what we're going to start with. So a equals 1, b equals 2, c equals negative 5. My h is at negative b over 2a. This is negative 2, that's negative b, over 2 times 1, which is 2 times a. So h equals negative 1. This cleans up to negative 1. I'll just write my vertex there. Now, if I want to find the y-coordinate of the vertex, I'm going to plug in negative 1 into this problem. Y equals negative 1 squared plus 2 times negative 1 minus 5. Negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 5. This ends up being negative 6. Axis of symmetry has not changed. It's still x equals h, where x equals negative 1. The y-intercept here is easy. Y-intercept, x equals 0. As we showed up here, it's just the value at the end. Okay? 0, negative 5. Let's see if we've got enough to make our graph already. That's negative 1, down 6 is down here. My axis of symmetry is right there. I have y-intercept is 0, -5, which is right there, which means I'm going to have a mirrored point over here. Now, I'm so far away from the x-axis that I really do actually want to find the x-intercepts. So the x-intercept is when y equals 0. This looks like I'm going to need the quadratic formula, so I'm going to pull down the next sheet and work on that there. This does not look like it factors to me. So what is the quadratic formula? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Our a, b, and c have not changed. Okay? Same a, b, and c. Negative 2 plus or minus 2 squared minus 4 times 1 times negative 5 all over 2 times 1. The bottom is 2. What do I have going on inside this parentheses? 2 squared minus 4 times 1 times negative 5 is 4. And then I've got negative 4 times negative 5 is plus 20 is 24. That's what's going to go underneath the radical. I'm going to eyeball it here. This is called estimating. I hope you like this. I think it's a little bit easier than pulling out a calculator. What's the square root of 25? Hopefully you all know that's 5, which means square root of 24 is just a little less than 5. So I'm going to go maybe 4.8. Might even be 4.9. But that's a little bit less than 5. I don't need exact precision because I'm just trying to figure out roundabouts where it's crossing that graph. So I've got negative 2 over 2 plus or minus 4.8 over 2. This is negative 1 plus or minus 2.4. My x-intercepts at negative 1 plus 2.4 is 1.4 comma 0. And if I do negative 1 minus 2.4, I get negative 3.4 and 0. And that's why I was just estimating, because I can't plot the exact square root of plus or minus 24 over 2 anyways. There's not enough detail, but I can get pretty close. 1.4 is about there. Negative 3.4, 1, 2, 3, 4. And you see they do look like they're mirrors of each other across the axis of symmetry. Oops, there we go. What is square root of 24? Now I'm just curious. How close did I get? 4.89. So I was close. I would have been better off with 4.9. But it's not really changing my graph that much. You guys ready for more? I know this video is getting a little long. Let's look at the completing the square method. And I'm going to go back to the problem we just had. F of x equals x squared plus 2x minus 5. We've done completing the square where we added the step to the other side. So maybe we'll do that here. It's not necessary, but I'll do it. What we did in the past is we added or we moved this to the other side. So I've got f of x plus 5 equals x squared plus 2x. And then what we did is we took that number and we cut it in half, divided it by 2, and we squared it. 2 divided by 2 is 1. 1 squared is 1. I add 1 on the right. I'll add 1 on the left. I've got f of x plus 6 equals, and then remember when we completed the square, we just brought our x down. Whatever this value is, we put it inside the parentheses, and we got that. Now I want f of x by itself, so I'm going to subtract 6 back over, and I get f of x equals x plus 1 squared minus 6. So that's doing it the way we did it before. And that is a valid approach to completing the square. What it really did though is it introduced an extra step. It really did. Instead, what we can do is we can create a little gap between our 2x and our negative 5. And what we'll do is we'll still do the same process. Take that number, positive 2, divided by 2, and square it. That's how we complete the square. 2 divided by 2 squared is 1. 1 squared is 1. I've added 1 on this side, but I do not. This is like balancing scales. If I add 1 on this side and elevate it up, it's not balanced unless I take 1 back away. So take 1 back away. Whatever you add, subtract. Okay. And this still followed the same pattern that we did before. We had the x, we had that squared. This number came down, plus 1. And now I've got minus 5 minus 1 is minus 6. And voila, look at that. Same thing. This is worth practicing and getting comfortable with. So, a couple more comments on if you don't complete the square. Because here, we can do the same thing we did before. What's HK? HK is -1, -6. Let me pull my old graph back out. -1, -6. We had it right there. So completing the square can actually speed it up some. Completing the square is only really helpful, I'll assume you paused it, If not, rewind it, take some pictures, or take some notes, I mean. Completing the squares, much more helpful. When A equals 1. Remember when we completed the square before and A didn't equal 1? We had to divide by it, and it was a pain in the ass. It really was. It was a lot of work. So the other approach we just did was called the vertex formula. The vertex formula, I didn't give you the name, I didn't state the name formally earlier. H was negative b over 2a. K was f evaluated at negative b over 2a. And we had y equaled ax squared plus bx plus c. The y-intercept was 0c. And x-intercept you had to solve for. Now, you can speed up some stuff with the x-intercept, because you can always use the quadratic formula. And if we use the quadratic formula, it always has that square root in there, that b squared minus 4ac. It's always in there. So if b squared minus 4ac is greater than 0, you have two real x-intercepts. If b squared minus 4ac equals 0, you only have one x-intercept, and it's your vertex, h comma 0. And if b squared minus 4ac is less than 0, then I've got a negative number underneath the radical. And negative numbers led to imaginary numbers. No real x-intercepts. And this will tell you the graph opens away from the x-axis. So you want to take a look at one? Okay, we're going to do two. We'll start off with the easier one. It's not the order I have them in the notes. We'll start off with the easier one. The easier one we're going to start off with is f of x equals x squared minus 6x plus 8. Now, if we completed the square, I'm just going to do it just so I can identify the vertex quicker, and then I'm going to go back and do the vertex formula, just so you can see it both ways. See it again. X squared minus 6x. I'm going to leave a gap, put my plus 8 over here. I'm going to do negative 6 divided by 2 and square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is plus 9. I added 9. I'm going to subtract 9. When I do that, this portion here turns into x minus 3 squared. And then I have 8 minus 9 is negative 1. So that's one way of doing it. And that's handy because a equaled 1 here. So I'm going to have a vertex at 3, negative 1. Let's get that the other way. My h is negative b over 2a. So let's just identify a, b, and c. A equals 1, b equals negative 6, c equals 8. There we go. Finally got that table the way I want it. So negative b is negative 6, because b was already negative, all over 2 times 1. Negative 6 is positive 6. 2 times 1 is 2. I got 6 over 2, which equals 3. Check. We had that. Then I'm going to do f of negative 3. I'm not negative 3, positive 3. F of h, which equals 3. Or f of negative b over 2a. That's how I was saying it earlier. I've got 3 squared minus 6 times 3 plus 8. Three squared is 9. Minus 6 times 3 is negative 18. So the y value, 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. Bam, I got my k. So, valuable piece of info. HK is 3, negative 1. My y-intercept jumps right out at me. I just get rid of the x's. I set them equal to 0. 0 squared minus 6 times 0, that's all just 0. The y-intercept at x equals 0 is 0, 8. Now, the x-intercept might take a little bit more work. Because y equaling 0 is where f of x equaling 0. This looks like it factors. It looks like it's x minus 4 and x minus 2. X minus 4 equals 0 or x minus 2 equals 0. So x equals 4 or x equals 2. That gives me x-intercepts at 4, 0 and 2, 0. And just to illustrate that b squared minus 4ac thing, I've got negative 6 squared minus 4 times 1 times 8. Negative 6 squared is 36. And negative 4 times 1 times 8 is negative 32. This is the square root of 4, which is, that's my b squared minus 4ac. It's greater than 0. So 2 real solutions. Finally, we'll get down to graphing it. Let's see, my HK is 3, negative 1, and it opens upwards. So I'm going to make my graph taller on the top than the bottom. Three, negative 1 is right here. My x-intercepts tell me I've got points at 2, 0, and 4, 0. That's good. It's following my mirror. And I have a y-intercept at 0,8. I've got one up here. This is 1, 2, 3 units away from the mirror of axis. I need another line. 1, 2, 3 over here. Ta-da! Presto magico. You guys ready for another one? In the interest of shortening the video, because I know it's been long already, I'm going to give you the problem, and then I'm going to give a pause, and then I'll give you the vertex and the x and y intercepts, and I want you to make sure you can get them on your own. It's important that you master these skills. Okay? And then we'll do one final topic. So f of x equals 4x squared minus 4x minus 15. That's the problem I want you to work with. Completing the square is going to be a little bit of a challenge here because a does not equal 1. You can do it, but I don't recommend it. So I recommend doing the vertex formula. So pause, take a few minutes, try to get this figured out. It's going to have fractions in it. I know you can do it. It's pain, but you can use a calculator. All right, I'll assume you paused. We have the vertex. HK is at negative b over 2a and f of negative b over 2a. If you plug those in, I got, let's see, I got 1/2 for h. And for k, what did I get? 16. Negative 16. So that's my HK. You should be able to reproduce that using x equals negative b over 2a and plugging it in. The y-intercept was easy. It's just the final number, 0, negative 15. The x-intercepts is when y equals 0 or f of x equals 0. This does factor. It's 2x plus 3 and 2x minus 5. And this is going to get you x-intercepts at negative 3/2, comma 0 and 5/2, comma 0. That gives us our axis of symmetry, x equals 1/2. And go ahead and graph it. Okay, there is a couple word problems in this section, and they're kind of fun related. So the first one's on projectile motion. And they have another one. It's like reading a graph. It's not that exciting. Projectile motion is awesome though. This is a quadratic function in the real world. So we've got home slice. He's got a bow and arrow. And let's say he shoots the arrow like that. It's going to go like that, and eventually it comes back down. Or we have a cannon. And let's say we, Ian is a human cannonball. Whee! There's Ian. He's got his Superman cape on. Bye, Ian. Ian's going to fly up, and he's going to come back down. These are parabolas that open downward. And we've got two formulas for them. We're going to stick to the one that's in feet. I think it's feet. So let me show you the formula. Your height at any given time t, height at time t, follows the equation negative 16t squared plus v naught times t plus s naught. V naught is your initial velocity or speed. S naught is your initial height. Or starting height, which is a good reason for using the S. Okay, let's put it into play. Question number 9, I believe, in the homework set is on, oops, I think I just clicked Word. Yeah, I did. Let me wait till we can close Word. This was a long section. 3.2 is quite a bit shorter. And in fact, I think you're going to like it. It's called synthetic division. It speeds up doing that long division with variables, polynomial division. It speeds it up a lot. Let's get rid of that. Okay. So I was tinkering with different questions here. Didn't go through all of them. That is not it. But let's take a look at that. So this is question number 9. Find a quadratic function whose graph matches the one in the figure. So let's zoom in on that. It looks like I've got the vertex is at -3, 3. That's my HK. Okay. So maybe I can do this. There we go. So homework. Looking at problem number 9. I have a graph where the vertex is at -3, 3. And they show me one of the x-intercepts is at -6, 0. And it looks like it crosses at 0, 0 as well. So how do I figure out what goes here? Well, my HK is going to be what goes inside the parentheses. Opposite sign for H. So H is negative, or H is 3. K is positive 3. So I'm going to put those in right now. But then, yeah. Now H is negative 3. When it goes in, it changes signs. My bad. So 3 and 3. What can I do with this negative 6, 0? Well, I know this has got to meet the equation. If I plug in negative 6, 0, I should be able to find out what's there. Right now, I have f of x equals a times x plus 3 squared plus 3. And I know negative 6, 0 is an option. This is when x equals negative 6, f of negative 6 equals 0. So I plug those in. Check this out. I get 0 equals a times negative 6 plus 3 squared plus 3. Well, negative 6 plus 3 is negative 3. Squared is 9. I've got 9a plus 3 equals 0. And this is just a linear equation. We solve for a, and I get a equals negative 3 over 9, which is negative 1/3. That's what I need to plug in right there. So I should be plugging in negative 1/3. Check our answer. Excellent. Is the number 10 the one I wanted to do? Nope. Is that another word problem for you to play with? Let's see, what kind of information should I give you? Number 10, she finds her daily costs are x squared minus 40x plus 620. So let's just talk through some of these word problems. Number 10, my cost function is x squared minus 40x plus 620. This tells me it's a parabola. A equals 1, so it opens up. And this is the cost in dollars when she sells X tacos. That's how much it costs. Find the number of tacos to minimize her costs. She wants to minimize C of X, the cost. The minimum cost what we've got going on here is this is the number of tacos, and this is the cost. The minimum cost occurs at the lowest possible point, which happens to be the vertex. They're just asking you to find the vertex. And when they say what are they asking for, they're not asking for a coordinate right now. They just ask for the number of units she needs to sell. Find X. That's what they're looking for in number 10. I guess I didn't have that up for you. Let me put that up where you can see it. I'm getting better at playing with this zoom thing. You probably like a smaller picture. You don't need David Jones all up in your face. Professor Hefe. That's what you're doing there. Take a when you're working on it, you'll have something to compare against. Similar thing going on here. Negative x squared. Number 11 has a negative x squared, which means a is less than 0 and it opens down. It now has a maximum value. So they're asking you to find the amount of range that maximizes it. You're looking for the vertex again. Here's an example of the projectile motion. Number 12, projectile motion. So in my problem, a toy rocket is launched from the top of a building 116 feet tall at an initial velocity of 188 feet per second. Now, I told you the function was h of t is negative 16t squared plus v naught t plus s naught. This is in American units, feet per second. The metric system, if you go into physics and engineering, you'll do a lot with metric. The negative 16 turns into a negative 9.8. A little less friendly to work with, but everything else stays the same. So that's the equation I need to work with. What is the starting information they gave me? I like seeing my face bigger. You're out of luck. There we go. A toy rocket is launched from 116 feet tall. And it's from the top of a building. So we got a building and lift off. And it's going to go up in the air and it's going to come down. This is 116 feet, 16 feet. That's my starting height. That's my S naught. Starting height. It says initial velocity. That's my V term. V naught is 188 feet per second. So part A, give the function that describes the height of the rocket in terms of time t. They use, see what they're doing here? They use S of t. I don't like it. H of t is much more descriptive. It tells you H is for height and it makes more sense. We're just being asked to plug this information in. Plus 188t minus or plus 116. Oop, that's an equal sign. Plus 188t plus 116. Did I use all the numbers they did? 116, 188, negative 16, good to go. Determine the time when the rocket reaches its maximum height. So the rocket goes up, the rocket comes down. launches in the air. Maximum height is up here. And it occurs at x equals t. So what they're asking us to find, part B, is find the vertex. H equals negative b over 2a. I got negative 188 over 2 times negative 16, which is negative 188 over negative 32. I'm betting that's a decimal. It doesn't look like it divides perfectly. Are you kidding me? And, oh, they want it in decimals. Okay, good. Nearest hundredth to the second. That's good. So its maximum height is after this many seconds. No, I'm sorry, that's t. Maybe that's why they use s. The vertex is a t f of t. We're used to using hk, and if I use h here, it gets confusing. I'm going to call that t. Maybe they're right. Maybe we should call this s of t up here to avoid confusion. So t equals 5.85 seconds. That's what my calculator says. That's the time. Rounding to the nearest hundredth would be 0.88. Now, I'm going to assume they want me to stick the 5.875 in, but let's find out. What is its maximum height? S of t equals 5.875. You really have to plug it in. So I'm just working on the calculator stuff right now. And I got 668.25. Let me do that again, just to make sure. Yep, I still get it. Now, the only way this is going to be off is if they wanted me to plug in 5.88 and I didn't. Let's find out. Good. For what time interval? I'm sorry, the rocket will be more than 347 feet above the ground for all values of the t in the interval. So the rocket's going up. It starts at 116. We know it goes all the way up. So right here, it's at 116 feet tall. Up here, it's at 668.25. They want to know, this is about 347. What values of t are it? 347 is the height. That's h of t. So to solve, or s of t. To solve this, we need to set s of t equal to that 347. 347 equals negative 16t squared plus 188t plus 116. I'll subtract 347. Do not round until the final answer, then round to the nearest hundredth. That tells me it's not going to be a pretty number. So, crap. Lame. T equals negative b plus or minus b squared minus 4ac all over 2a. I've got negative 188 plus or minus 188 squared minus 4 times negative 16 times negative 231 all over 2 times negative 16. Okay, this is not fun. I know why you guys don't like doing the homework. It's pain, right? Just got to take it slow. Let's do the inside the parentheses first, or inside the radical sign. I know the bottom 2 times 16 is 32. I'll do that. I've got 188 squared times 4 times negative 16 times negative 231. You've got to be kidding me. Now, just because it's ugly doesn't mean it's wrong. So what is that? What's the square root of that? Let me make sure I did that right. Nope, I got something different right there. What did I do the first time? Yep, that is not the right number. That's why you double check your work. When it looks really crappy, it's always worth plugging it in again. Let's work with that. So I get negative 188 over negative 32 plus or minus square root of 50,128 over negative 32. This might even be easier just doing them like this. Leaving it over negative 32 and dividing by the end. Doing negative 188 plus or minus the square root of 50,128. So let's do the positive one. Negative 188 plus the square root of 50,128 over negative 32. So I'm just entering in my calculator. Negative 188 plus the square root of 50,128 divided by negative 32. T equals negative 1.12165. And they want nearest hundredth, so negative 1.12. And then we'll do the negative version. I hope I did not make a mistake in here somewhere. They want an interval. So negative 1.12 1.12, 12.87. If they don't take that, I'm going to change t to equaling 0. That's not true. Something's off. I've done something wrong. Because I know it started off at 116. That's when t equaled 0. It was not above 347. Which means I made a mistake somewhere. Where did I make the mistake? That's not right. I know it has to be after t equals 0 because that's when it started. And it was only at 116 feet high and it launched up. It should have crossed at some later time. So I made a mistake somewhere. Let's go back and find it. I subtract 347 from both sides. I get negative 231. Ah, I know what I did. See that minus sign right there? Minus sign. One single minus sign caused the whole hiccup. So let's see what it was really going to be. That's where it was. I screwed it up there. Okay. So if you were going along and you didn't get that 50,128, you probably would have been raising your hand by now. But since this isn't live yet, you had to work with me. But hopefully you saw and learned something about my process of thinking. I knew the answer was wrong before I even plugged it in because I started off at a higher height than at t equals 0. If I go backwards in time, something's off. So I'll do the positive version first. Plus the square root of 2560 divided by negative 32. There we go. 1.39413 or 1.39. And we do the negative one. That should work. Good. All right, so that was a lot of work. When will the rocket hit the ground? So part D, I'm going to leave for you to do, but let's reason it out. What's going on when the rocket hits the ground? What's really going into effect here? We've got our rocket, and it's launching, and it's going to go up, and it's going to hit the ground. H equals 116 here. What's H right here? 0. If the building is 116 feet tall, we call the bottom of the building 0. So what we're doing is setting S of t equal to 0. You've got 0 equals negative 16t squared plus 188t plus 116. Oops. Plus 116. And go ahead and solve for it for there. That answered all the questions on this problem. And I think we've covered a good wide range of material. So we're going to call that a wrap on section 3.1. I'll do 3.2 shortly. Let me leave that up a little bit longer. (3.2) is shorter. It's a synthetic division is a faster way of doing polynomial division. I think you'll like it. It's pretty easy. It's really easy. It's multiplication and addition and subtraction. And something I call the skybox. All right. Well, I hope you enjoyed our presentation. This wraps up 3.1, and we'll get 3.2 going, and 3.3, 3.4 this week as well. I'll be working on some over the weekend as well. I want to get as many videos pumped out so that maybe we can go live next week. If anything, I'm going to make sure we have all the videos for the semester, or at least through Easter break by the time Easter break starts, even if I don't get to go live. Please email me. I put out my Google text number. You can text me. Use Ask an Instructor. Great tool. Check it out. Ask my instructor. Mr. Jones, I don't know how to do part D. Can you get me pointed in the right direction? Let me know what part you're on, what's confusing you. Maybe you were able to get started, but you didn't understand where to go next. Let me know. You click send, and it'll send me the question with your numbers and everything. It'll have A, B. If you ask it D, it will have A, B, and C filled in. So I'll know all the previous work, and I'll be able to jump right in and help. All right? Well, peace. Let's get this. Ooh, I don't think you wanted that. Stop recording.